Welcome to the introductory session on command line environment. Why would we want to learn about command line environment? Because when we are able to type out commands, then we are capable of using Linux to its fullest extent. We can combine these commands to form a script, and then we can use these scripts to be launched at specific times and thereby automate some of the tasks that we would like to do using the Linux environment. So the command line environment should be seen as not only a way by which you type out instructions to the computer, but also as a path towards automation. On the screen, you are noticing there are two apps that are giving you the command line environment. My favorite would be the app called Terminal on Ubuntu GNOME environment. It has flexibilities to control the font size, the colors, etc. It also can open multiple tabs as I am showing you here. There is another terminal emulator called Xterm, which is here you can see, and it does not have many of those features to customize the appearance. And a third terminal emulator would be Quake, which we activate by pressing the key F12, and by pressing it again we can actually deactivate. Once you install it and run it once, then it would be in the background listening to your command, and you can open it or close it at your wish. There is another terminal emulator called Console, which is available for the KDE environment on Ubuntu as well as other Linux variants. For most of the session, we will actually look at the terminal app, which is acting as a terminal emulator for us. Let me maximize the window so that we can see the commands clearly. Now what you are seeing on the screen here is called the command prompt. So if you just keep pressing the enter key, then you would see that the shell is asking you for some input, and it is prompting you for that by showing this string, and this string is called as the command prompt. And you can actually now clear the screen by typing the command clear, and the cursor will be taken to the top of the window. Now one of the first things that we must do when we open a command line environment is to check where are we with respect to the file system. pwd is a command to show you the present working directory, and normally you will see that you are in the home directory. When you first log in and open the terminal environment, you will be placed in the home directory of that particular user you are logged into. In this case, the home directory is /home/username, which is what is configured for this particular account. The next thing that we normally do is to type ls, which is to list the names of all the folders or files that are in this current directory, and you would see that there are certain folders that are available as part of the GNOME environment: desktop, documents, downloads, pictures, videos, etc. And you want to know what shell is actually responding to our commands. You may want to list the processes that are running right now, and you would notice that there is a bash that is running. So our shell that we are interacting with using this terminal emulator is bash shell. There are many other shells, we will come to that in a moment. And what operating system are we using? That you could actually know by typing the command uname. And let us say we run many such commands and we would like to clear the screen. We could type the command clear and press enter, and the entire display will be cleared. You could also, for example, type a command and then press Ctrl L to also clear the screen. And after you have played around a bit, you want to exit. What you would do is type the command exit to come out of the shell. Alternatively, you can also press Ctrl D. So I can now press Ctrl D and come out of the shell. We have an Xterm that is running in the background. We would like to come out of that, so we would type exit and then come out of that. And when I press F12, I am opening the Quake terminal, and you could have of course you can exit from that also, but when you press F12 again, another shell is actually shown to you. and I can run the same commands there and get the same output. Irrespective of the shell or the terminal emulator, the commands that you are sending are being responded from the operating system. Now let us just wrap up what we have discussed till now. So what have we been doing now? So what we did was we opened a terminal emulator, and most of the things we did was on terminal app, and we ran some commands: pwd present working directory, ls to list the folders or files in the directory, ps to look at the processes that are running in that particular shell, uname to look at what is the operating system that is actually responding. So these are some of the commands that we started off, and we were able to clear the screen by pressing Ctrl L and also come out of the shell by pressing Ctrl T. Now if you look at what we have been doing, there is a command prompt that is there, and then there is a command that we have written. So let us look at the anatomy of this particular command. So you see that when we write a command, the command prompt in front of the command has many portions which can be configured separately. We will discuss about that when we come to the variable called ps1. For now, you see that the command prompt has the username and then an @ symbol, after that the name of the machine, followed by a colon, and then the path where the command is being executed, and then a dollar to signal that from then onwards you can actually start typing. And the command that we typed is ls, and sometimes for some of the commands we need to give some options, and here is an example: ls -a. Now let us look at how this command would look like. Now let us look at these commands a little more in detail. So we have typed a command ls to look at what are all the files that are in the current directory. We can actually now give an option to that command. I would give an option -a. So most of the Linux options would have a hyphen or a minus sign in front of them, and you would see that a lot more files are being displayed. So -a option will list files which also have a dot in front of them, which means that those are basically hidden from the user for routine operations. So if you press ls, you would see the files that are used by the user in a routine manner, and -a if you give as an option, then ls would give you the hidden files also, which are having a dot in the first position of the name. And if you press ls -l, the list of files is displayed in a different manner. This is called the long format, and we will discuss these fields in detail in a moment. You can get help on any command in Linux thanks to the manual pages that come bundled along with the operating system, and you can pass on any command name as an argument to the command man and then get help on it. So let us ask for a manual page on the command ls, and you can see the help for the ls command. You can read this to expand the scope of how the ls command would work for you. The most frequent options that are used with ls are ls -a to list all the files, and ls -l to list the files in a long format. So here is what we have done. We have run the command man with the argument ls, so that we are looking at the manual page for the ls command to understand various options that can go along with the ls command. Now the manual pages come in many sections, and this is just a textbook information to let you know that the manual pages cover various aspects of the operating system, and the section 1 is where the shell commands are being described. So you can actually ask man pages to be displayed in the section 1 for the command ls. So here what happens is that when you type man space 1 space ls, 1 becomes an option and ls becomes an argument. Let us explore the file system of a Linux operating system. Luckily for us, the file system hierarchy standard version 3.0 is what is followed by all the Linux operating systems. irrespective of the variant that we are using. So we are using the Ubuntu 20.04 LTS version, and you could shift to any other version of Linux, and you would see that the folders will have the same name and they will be located in the same hierarchy as we will be exploring shortly. Why do we need to understand how the file system hierarchy is? The reason is that when we log into the system and when we open a command line environment in a shell, we are placed at a particular location in that hierarchy, namely our home directory, and we have permissions to create files in that directory and perhaps also in some other directory such as /temp. But we do have read access to many files that are there in several folders, and we should be able to traverse the hierarchy and locate commands corresponding to specific applications that we would like to run. And very often we need to identify the right location of a library file because it is required for some compilation of a program. The files corresponding to libraries or header files to compile our codes, and the ability to traverse the file system hierarchy will actually determine how soon we are able to debug our difficulties with respect to the compilation requirements and get on with the program development. So it is very useful to familiarize ourselves with file system hierarchy of Linux. So here is a sample of the file system hierarchy. The / or / simply is the root directory, and that is a starting point for the file system hierarchy. This character / is also used as a field separator to indicate the path to any directory, as we see now. Let us say, for example, we want to refer to this directory called bin, which is under a directory called user. Then you would write that path for this bin as /user/bin, and you would see that there are number of directories with specific names which will actually have their meaning as described in the file system hierarchy standard 3.0. The user directory is here, the home directory for a user, and under the home directory there are folders which are created by the operating system while creating that account, and there are also folders that the user can create for herself or himself. We can explore the file system hierarchy by first understanding how to actually construct the path of any directory. So / is the root of the file system and also the delimiter for the subdirectories, and in every directory there are two special files. One is called the dot, which is referring to the current directory, and the other is double dot, which is referring to the parent directory. So if you type the command cd space dot, nothing will happen because you are trying to change the directory to the current directory. So there is no change in the directory position. If you type the command cd space double dot, then you are going one level up in the file system hierarchy. So you could traverse the file system hierarchy up and down by changing the directory. If you want to go from the user's home directory upwards, you would say cd space double dot, and then you would be in home directory, and then cd double dot, you will be in the root directory. From the root directory, if you actually give the absolute path, you could actually go anywhere you wish, or you could actually use the cd with the name of the directory to traverse one level at a time. Let us explore the file system hierarchy using the system where we are trying to demonstrate the command line environment. So where am I right now? I am in the home directory of the user I am logged into, and when I type ls, I see that there are certain files that are listed here, and when I press ls space -a, then we notice that there are two special files here, one that is dot and another that is double dot. There is a special directory called double dot which is allowing us to traverse one level up in the hierarchy. So let me change my directory to one level up, and you would now see that we are now in /home. And if I type this command once more, then we are in the root folder. Verify that we are in the root folder using the pwd command. Now if I press cd, then we are going back to the home directory, which means that the cd without any arguments will take you to the home directory. I now press Ctrl L to clear the screen. Now let me go back to the root folder, and using ls we will see that there are certain folders that are there in the root folder, and with the -l option we can actually see the long format, and it actually indicates several things about the file system that we can already start getting familiarized. For example, the very first character shows that there's an L here, and for some directories it is a D, and the difference between these two is that the L indicates a symbolic link, so which means that the bin folder of the root directory is actually a symbolic link to a folder with the same name in the user directory, and the D here means that it's actually a directory by itself in the particular location. Now boot directory is where the Linux kernel is located, which is what gets executed when the system is starting up. And there are many such directories here, and let us explore one of them. So we'll go to the user directory, and then from there we can go down to the bin directory, and let us look at what are all the files that are there. There's a lot of files that are here, and many of these are actually commands that we would be using as we go along learning the command line environment. And we can now go back to the home directory, verify that we are in the home directory. In this manner we can actually traverse the hierarchy of the file system and explore what is there in which folder. Now let us look at the organization of these folders as per the file system hierarchy standard. The bin directory in the root folder should contain the essential command binaries or executables. These are the commands that every user in the system are supposed to be able to run. Sometimes this folder can be a link to the folder in /user/bin, and that is a matter of only a choice from the company that packages the Linux for you. Boot folder contains the bootloader, which is what executes when the system starts up. Dev folder contains the device files. One says that in Linux everything is a file. So every device that is connected to the computer is actually a file as far as the representation is concerned in the file system hierarchy. etc folder contains configurations of various services which are specific to that particular machine. The lib folder will contain the libraries or shared programs as well as kernel modules. The media folder will contain folders which are created when you insert a removable device into the computer. For example, if you insert a USB disk, then in the media folder a folder is available which will contain the file system for the USB stick, which you can explore. And when you unmount or eject the USB stick, then that folder would also disappear. Now /mnt is a folder where you could have mount points, that is directories which are made available to traverse the file system of those respective hardware or hard disks. /opt is a folder where application software packages are installed, particularly in high performance computing environment. Run is a file system to have the data for the running processes. Sbin is a directory where the executables meant for system administration are kept. It is expected that normal users in their routine operation of the system do not require to execute any command which is located in this particular folder. SRV is a folder that contains the data for FTP or HTTP services. TMP is a folder where temporary files are located. Every user will have permission to write files to this particular folder, and one should not expect such files to be available after the rebooting, because in many computers the configuration would be such that upon rebooting the /temp will be cleaned up. /user is a secondary hierarchy for the file system which is shareable. By that we mean when you have a high performance computing environment, then you could have the user directory shared across multiple computers, so that you don't have to actually have that much of hard disk space replicated across all the computers. /var is a folder where variable data is stored, such as the log files for various system services that are running in the background. Now let us come back to the command prompt and look at these directories. So we go back to the root folder and you see that there's a user directory, and in that there is a bin directory, and you have got all these commands. And we also noticed the /etc. So look at what is all there in /etc. You would see that a whole bunch of files are named as .conf, which is basically the configuration for those respective services. And /var is a folder where we said that log files will be located, and they are all in this folder called log. And you would see that there are logs that are created for various services. Now let us look at the /dev folder, and you would see that the display would have a different character in the long format of the file listing. The C here shows that it is actually a character file, which means that you could read from that particular device character by character, which is typical of devices such as the terminals. And there are some files which would actually have the first character as B, and these are called as block devices. Particularly it is for the hard disks. So when you want to read from a hard disk, you would read one block at a time. Typically a block would be either 512 bytes or 1 kilobyte or even 4 kilobytes depending upon the configuration, and in Linux typically it is 1 kilobyte. So if you see these devices which are listed as SDA 1 up to 7, these are block devices which are available as files as far as the file system hierarchy is concerned. Let us look at the /lib folder, and you would see that this folder would contain many files that would have a pattern which would have a number in the end, which is typical of library files with version numbers that are there as a part of the file name. You can now explore the file system at your convenience, and as long as you are using the commands like cd and ls, there's nothing that you can go wrong. And make yourself familiar with the file system hierarchy and understand which part of the hierarchy is your home directory, and everything below that hierarchy is what is owned and writable for you. So you could actually play around with it, and you will notice that you cannot actually do much changes to the file system hierarchy beyond your home directory, which is characteristic of the secure manner by which the file system is configured in Linux operating system. Before we wrap up, let us look at the hierarchy of the user and var folders, which is quite extensive. So in the user hierarchy, it's a secondary hierarchy. You would have a user bin folder which will contain commands that every user is expected to be able to run, and there's a folder called user lib where library files are located. User local is a directory where certain applications which are specific for that particular system are installed, which may not be common for all the operating systems in that particular variant. User sbin is a directory where system administration executables are located, but these are non-vital because the vital ones are available in /sbin itself. What do we mean by that? It is that when the machine is in a single user mode or in maintenance mode, then executables which are required to mount the file systems or perform system administration tasks that are not dependent on any network or any remotely located file systems that are mounted on the system, then you would actually use /sbin. User share is a folder where the architecture dependent data is stored. User include is a directory where the header files for C programs are all to be found. So when you started the hello world program in C, for example, stdio.h is a header file that you include, and you would see that it is located in this particular folder. User src would be containing the source code of various applications that are installed on the Linux operating system, if you have chosen to install those packages. The var hierarchy is also important because we need to know where to find the log files. So in var log, the log files for various services will be located, and in var temp, some of the temporary files that are to be preserved between reboots will be located, and Where lock is a place where the lock files are there for processes which would like to have exclusive access to certain files during certain operations that prevent any clash of information. Where lib is a variable state information. Now here is some logic or reason why there are such folders with this kind of a hierarchy. So what we mean by a shareable folder is that a file system which can be shared across computers. This is essentially to conserve the storage and also to provide uniform file system to multiple computers, particularly in high performance computing environments. And sometimes you also have what is called the static and variable kind of file systems or directories. The static ones are ones which do not change during the regular operation of the computer, whereas variable ones will change. For example, when an email comes, a folder corresponding to that particular user's inbox would change. So that would be in the variable folder, such as where by mail by the username. However, when you execute commands, the executables are not going to change and they will all be static files. There are some folders which cannot be shared across computers because they contain configurations specific to that particular computer. /etc and /boot are some such folders. And there are some folders which are not shareable across computers, as well as they are also variable with the regular operation of the computer, like for example where lock or where run. So this is a logic why there are different folders, and a standard has been defined to ensure that users who log into machines can actually identify these folders irrespective of the specific version of the operating system they are using. And across Linux variants, you would find that the file system hierarchy is maintained. And this helps us navigate the file system hierarchy and locate the files that we are looking for to execute them or to use them for linking purpose while we compile some of our programs. I hope you got a sense of the file system hierarchy, and I urge you to explore the command line environment and make yourself familiar with the file system of your own computer, and you would soon be comfortable with locating files that would arrive onto your computer as you run commands or download things and move around the files for your work.